I hope you watched the videos and enjoyed watching them. I hope you took some notes. I'm going to give you the LJ version on how to do this. It's the simplest way, I believe, to do it all. Oh, I just noticed a wrong date up there, and I'm sorry. That should be 2014, not 15. I guess I'm ahead of myself. So today we're going to work on simplifying radicals. So what is a radical? This symbol right here is the radical. It indicates that you should take a square root. Sometimes you will see a number in this area that's called an index. If it's a square root, it would be a 2. If it's a cube root, it would be a 3. If it's a fourth root, it would be a 4. You'll learn about cubes and fourth roots later. For now, these are square roots, and for square root, you do not have to write an index. Also understand that using a radical is the opposite of squaring a number. Remember, squaring a number means multiplying a number by itself. So here's a sample problem. You would read this: the square root of 16 is 4. You're looking for a number that when you multiply times itself yields the number under a radical. And we all know that 4 times 4 is 16. So 4 is the square root of 16. Here are some for you to do. I'm going to read you the number, I'm going to read you the problem, and when I say answer, you answer. The square root of 25 is answer. The square root of 100 is answer. The square root of 64 is answer. The square root of 81 is answer. Hopefully you got these all right. These are all perfect squares. So the square root of 25 is 5. 10 is the square root of 100. The square root of 64 is 8. And the square root of 81 is 9. So 9 times 9 is 81. 8 times 8 is 64. 10 times 10 is 100. 5 times 5 is 25. Okay, try this one. I'll give you a little Jeopardy music here. Do, 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 do. Okay, that should be enough. You should know that there is not a number times itself that gives you 72, because 72 is not a perfect square. 8 times 8 is 64. That's too small. 9 times 9 is 81. That's too big. So how do we work with this square root of 72? Well, the first thing I want you to do is to do a factor tree. Oh, sorry, I forgot I put it in this slide. This was a trick question. It's not a perfect square. So are you looking for a solution? If you are, use your calculator. If not, you should simplify it. And for everything we're doing today, we are just simplifying. When you simplify, that means most likely you will have a radical left in your final answer. So here we go. How to simplify. First of all, do a factor tree. Remember, circle all of your prime numbers. If you do the upside down cake method, all the numbers on the outside will be prime. The next thing I'd like you to do is to rewrite all that factoring under the radical. This is still 72. 3 times 3 is 9. There's your 9. And 2 times 2 times 2 is 8. So here's my 8 times my 9, which still gives me 72. Let's think of these numbers being in radical jail. One can escape if it can find its exact pair to match with. So here I have paired these 2's. This 2 disappears while this one escapes. This 2 doesn't have a match, so it's stuck. These 2 3's are in a pair, so this 3 disappears while that 3 can escape. Now you're left with 72 equals 2 times 3, those are my escapees, times the 2 that got stuck. So here's what your notation might look like. Notice that in this last step, I multiplied the escapees back together to get my 6. Here's one for you to try. Here are your steps. First, find the prime factors. Second, rewrite the prime factorization under the radical. Third, can anyone escape? And if they can, do it. Remember, to make them have their partner has to disappear if they escape. And if you have many outside the radical or inside the radical, you multiply them back together. Pause the video and try this one. Here is what my work looked like. Here's my factor tree, 2 times 25 and then 5 times 5. Here I wrote it out under the radical. 2 was stuck. This 5 disappeared. This 5 escaped. So my solution is 5 onto the square root of 2. Here it is written in a nice, neat form. 600. I've done this before I gave you a chance to practice. Sorry about that. But I used an upside down cake method this time for factoring. I know some of you like to do it that way. So when you get the prime factorization, I wrote it all under the radical. You can see this 2 disappears, so that can escape. Stuck. 3 has no partner, so it's stuck. This 5 disappears, that 5 escapes. Notice that I grouped all my 2's together, all my 3's together, and all my 5's together. That makes things easier. Here is my leftovers. Here are my 2 escapees, a 2 and a 5. Here are the 2 that got stuck underneath. So you multiply everything back together. 10 onto the square root of 6. Here are your homework. Good luck.